Okay, good day. Okay, so in this video, we will be talking about absolute dependent motion of two bodies. Okay, so will be the second part. Okay, so when we say absolute motion dependent, okay, so we talk about at least two particles, okay, in which is pulling each other. Okay. So let us say one, okay, is heavier than the other. Let us say this one is about 63 kilograms. While this, okay, let us say this is mass 2. Let us say we have mass 1 at 38 kilograms. Okay, so how do we solve this one? Okay, so in the previous video, okay, so we um, able to name the different formulas that we can use to solve this type of problem. Okay, okay, let us say this M1, so let us say this is S1 and this is S2. So therefore our formulas here will be equal to S1 plus S2 is equal to the total length of the pulley rope. Okay. So in order to get the formula for velocity is we differentiate this one. So we get V1 plus V2 since LT is constant. Okay. So this is actually constant. Why? Because no matter what happens, neglecting this pulley, this S1 and S2 is equal to the total length of the rope. And the total length of the rope here is constant in length. So therefore, it will become 0. And then, if we go on with the acceleration, we get A1 plus A2 is equal to 0. So which means the acceleration is equal to negative A2. The V1, okay, the V1 is equal to negative V2. And the A1 is equal to negative A2. Okay, so these are the three formulas, okay, that we can use. But somehow, let us complete this problem. So let us say we are asked what is the acceleration. Okay, so as you can see, these two bodies is moving. If it moves downward here in this side, since this is the heavier mass, okay, this is the heavier body. So if it moves down at a certain distance, so it will also displace at a certain distance vertically. So this will also displace the same length. Also true with the velocity and the acceleration. Okay? So in this situation, if there is only two, so we can say by the use of just some logic, okay? So both of them has force. Okay, so let us say this force 1 is equal to mass 1 times acceleration 1. And here, your F2 is equal to mass 2 times acceleration 2. But somehow, since A sub 1 is equal to A negative 2, so therefore, we could say that the acceleration of these two bodies are the same but in opposite direction. One is moving upward, so it's positive, so this is A1, and one is moving downward, which is A2. Since there are only two particles, so this A1, we could say this is A, positive A, while A sub 2 is the negative A. Both are the same. Okay, so we can say A sub 1 is equal to negative A sub 2 is equal to A. And we need to find that A. We have 38A, and then F2 is equal to 63A. So here we are. So other than the acceleration caused by these two motion, so they actually have the weight. Each of these has a weight, okay? So the forces involved is 38A and the other is 63A. But please remember that there is also gravity. And that gravity force, we have weight 2 is equivalent to, okay? Let us say the weight. There is also some weight here. Okay, so let us add another arrow. So we also have a weight. The weight here, let us name it as W2 is equal to the mass 63 times 9.81. And here, we also have its own weight, which is downward. So we have W1 is equal to the weight 38 times 9.81, which is the acceleration due to gravity. Okay, so how do we play with these numbers? Okay, so as you can see, if this 63 kilograms, okay, if this 63 kilograms, for example, okay, so if this 63 kilograms will move at that direction, this other weight will move at that direction. Okay? If it moves downward, this moves upward. Okay? And then we could use this weight and these forces. So here, the weight minus the weight of this smaller particle, okay, this big body, okay, this heavier body minus the weight of this lighter body is equivalent to the force F1 plus F2. Okay, so this W1, the weight of this first first body or this part will limit the movement of this other body. So therefore, W2 minus W1, which is equivalent to 63 times 9.81 minus 38 times 9.81, which is equivalent to the force 1, 38A plus 63A. So in this problem, we can actually solve the acceleration. And that acceleration is equal to a sub 1 and equal to a sub 2. Although opposite in sign. Okay? Okay. So from that problem, we can actually solve the acceleration. So 63 minus 38 times 9.81 divided by 101. 38 plus 63. So we got 428 meter per second squared. So now we could say that a sub 1 is equal to 2.428 meter per second squared moving upward, and a sub 2 is 2.428 meter per second squared moving downward. Okay. Okay. So the shortcut formula for this one is by just using this formula. Okay, so we can use this formula other than the more comprehensive one. So if there are only two bodies involved, you can use this formula. The actual acceleration is equal to mass, okay, the bigger mass minus mass smaller over the sum of smaller and bigger mass, and then multiplied by the acceleration due to gravity. So this is the formula. So here, I use 9.81 meters squared for G. If you are using SI and you use 32.17 feet per second squared for US. Okay. So it depends, okay? So be sure, okay, M bigger is the bigger mass. And then M smaller is the smaller mass, okay, logically. So either you use this formula or you use this more comprehensive formula. But somehow, in this formula, in this solution, you can actually compute the velocity and the displacement other than the acceleration. So this formula is a special case formula that can be applied in this simple problem. Okay, so I hope you understand something in this video. Okay, so thanks for listening.